Are you uncertain about the differences between data analyst and data scientist roles and which one would be a better fit for you? I will compare the two job families across 4 categories: goals of the role, qualifications required to apply, skills you will need on the job, and of course, salaries. I will highlight the similarities and differences and the pros and cons for applying for one or the other so you can make an informed decision. Data analytics tends to be retrospective. So a data analyst aims to answer questions such as what happened and why did it happen using data. They usually work on well-defined questions to drive some sort of decision. Some typical questions are in marketing, for example, what marketing channels are driving the highest return on investment? In finance, how does the credit score correlate with loan default rates? Do we need to change our policies? In healthcare, which treatments lead to the best outcomes for patients? All of these questions can be answered by looking at historical data and performing classical statistics. Advanced techniques are rarely required. These questions are also asked quite regularly, so a data analyst would develop dashboards or reports so stakeholders can easily find answers and make decisions. A data scientist, on the other hand, often works on forward-looking projects. The focus is on innovation, strategy, so they tend to work on ill-defined and vague problems, trying to identify new opportunities. Typical questions a data scientist would answer are: in marketing, can we forecast customer behavior and predict which marketing channel is best for an individual customer? In finance, can we detect fraudulent transactions in real time to reduce financial loss and improve customer trust? In healthcare, can we predict patient health outcomes and readmission rates based on electronic health records? Classical statistics is usually not enough to answer these questions. Data scientists often use machine learning, deep learning, and other advanced modeling techniques to solve problems. It's also often unclear whether a problem can be solved at all, leading to many failed and unfinished projects. For example, I worked on more than 20 different data science projects over 6 years before I started teaching full-time, and only 2 models I developed were successfully deployed, and a handful of other projects were published in various scientific journals. The other projects were terminated because they were not feasible. Both roles offer unique challenges and rewards, but they cater to different personalities and work preferences. At the end of the day, your job satisfaction and personal fulfillment should be the most important factor when applying for jobs. So consider whether the thrill of solving complex problems and pioneering innovative solutions, or the satisfaction of supporting critical business decisions is where your passion lies. Stick around until the end, because we will discuss what's probably the second most important factor when applying for jobs: salaries. Data analytics usually has a lower barrier to entry, because a master's or a PhD degree is often not required. A bachelor's degree in computer science, data science, statistics, or mathematics is sufficient because you will need basic math and stat skills for the job. Of course, master's degrees in data analytics do exist, so you could consider completing one of those programs to boost your chances of landing a job. Data science usually requires at least a master's degree in some math-heavy and computationally intensive field, but often a PhD is required. That's because you will use more advanced statistical and mathematical tools to solve problems. You will need a deep understanding of statistics, linear algebra, and calculus to succeed in the field. I have a PhD in astrophysics and solved partial differential equations for a living back in the day. So, transitioning to data science was not too difficult for me. I used Python, I knew how to work with and visualize data, and I used complex numerical algorithms to solve challenging questions. I was not familiar with machine learning and deep learning tools at the time, but that was something I could pick up in a couple of months from online courses and practicing on Kaggle. If you have an advanced degree, but you think you would be happier as a data analyst, don't worry too much. Just apply for data analyst jobs. In fact, being a bit overqualified for the role you apply for might help you land one in today's job market. Keep in mind that your happiness and job satisfaction comes first. If you want to work as a data scientist and you don't have an advanced degree yet, be prepared for a difficult and grueling path ahead. This is where the roles are most similar, I think. Both roles require good problem-solving and coding skills, math and statistics knowledge, and excellent communication skills. It's the depth of knowledge that might differ. While the trends might differ from discipline to discipline or even from company to company, generally speaking, data analysts are expected to use Excel, Google Sheets, Tableau, Power BI, SQL, and some Python too. Data scientists usually use SQL, Python, R, and other tools necessary for code development and bug tracking, handling large data sets, and deploying machine learning models. The coding requirements tend to be more stringent for data scientists because they might be expected to develop and contribute to larger code bases. As I already hinted before, you will need more stats and math if you work as a data scientist because you will likely use more advanced methods like machine learning and deep learning. As a data analyst, you will need a solid basic understanding of statistics and math, but the focus will be on descriptive analytics and data visualization. You will need to know how to handle and wrangle data well in both roles. That's why SQL and Python are common requirements. It's probably no surprise to anyone that data scientists tend to earn more. Entry-level data analysts take home around $60,000 to $80,000 in the USA, mid-level analysts can expect $80,000 to $100,000, and senior data analyst salary is around $100,000 to $130,000. Entry-level data scientists can expect $80,000 to $120,000, mid-level data science salaries are in the range of $120,000 to $150,000, and senior data scientists can earn upwards of $150,000. These salaries of course depend a lot on your location, number of years of experience, and your sector. For example, entry-level data science salaries at big tech companies in Silicon Valley usually start at around $150,000 to $200,000 or more. This is a double-edged sword though. While data scientists tend to earn more, these jobs require more education and advanced skills, so if you have those, companies will of course pay you more. On the other hand, these jobs are also much more competitive and difficult to land. While I'm not actively applying for jobs, I have a pretty good idea of the state of the current job market because my students give me a first-hand account. It's not looking great at the entry level right now. Some of them literally apply for hundreds of jobs, and if they do get a callback, they now have to go through 5 or 6 rounds of interviews to maybe potentially receive an offer. Applying for data science jobs is pretty daunting and stressful nowadays, so check out my previous video on how you can improve your chances of landing one.